And I turned up and they're like, how have you had a whole year without doing a COVID test? I was just like, stay at home. I don't try and touch anyone, go near anyone. I don't lick windows on trains. So, happy days. But actually, I wanted to just show the crime scene off that was in my house that I was talking about earlier with people this week. And hi, everyone, if you're eating dinner.
Hello and welcome to alt.net, by the way.
We're just
wondering what you tuned into.
All right, so I'm going to try and get the camera position right. All right, so there's my sad-looking dog because they're walking around and, oh, look. Oh, there's blood everywhere. This is what you want to come upstairs to. It's so good. It's the best.
Oh man. Where was all this blood coming from?
That's coming from the dog's foot.
Ouch.
So when you clip a dog's toes or nails or whatever else, there's a quick in there. If you go too much, we had blood spurting and all sorts of things. It was fantastic. We tried bodging it up with Selly's No More Gaps. Product placement for Selly's there. That didn't work.
On the dog's foot.
Yeah. Just like on the toner, just jam it in there. Tried super glue, couldn't get a grip. Tried doing like it was just like, wow. It was great. So yeah, that was my day, apart from actually doing paid work and things. Cool. So James, do you want to intro things?
All right. Thank you, Richard. I think you might have already introed things, but welcome to the Sydney Alt.net user group. This is the more formal part of the evening, starting when we talk about technology-related things rather than clipping dog's feet, mainly.
Or COVID tests.
Or COVID tests. Actually, that's pretty relevant for everyone. But hey, can everyone see Richard all right? It looks a bit blurry to me.
Is it really?
It's coming through a bit blurry.
Yeah, not to worry. We can hear you all right, Richard.
Yeah, all right. Well, I'll just be quiet.
It's looking good.
Still see the shiny bottom of your head.
Fair enough. So we're very lucky to have two Richards on the show today. We've got Richard Snowflake and Richard Oldtimer, who is our usual Richard.
Oh, wow. I just get Oldtimer shoved on the end now. That's why I'm on my 56K dial-up, apparently.
Yeah.
So we're going to try and do a bit of an interactive session today, like a bit of an interview, a bit of a presentation. And Richard's going to tell us all about Snowflake and why it's cool and different to other things. I mean, the guy in the middle, the Snowflake Richard, mind you. The other Richard's going to ask clever questions that he thought about earlier.
Well, maybe.
Maybe, yes. So we've got the usual giveaways. So we've got blurry. We've got comments from the crowd. Perhaps blurry is best for Richard. So there you go. So we've got the usual giveaways of the 2 JetBrains licenses. So listen closely, and I'll ask you 2 questions at the end. And as usual, they let you have any of the JetBrains products for a year and longer than that if you don't need support for them anymore. You get a year.
They don't come around to your house and take them back.
No, they don't.
That's pretty cool.
So it's pretty decent.
That's nice.
Richard, you can't enter because you're talking. You have to turn up as an event, as just an attendee instead.
Yeah, you'll have to come to next month if you want to win, unfortunately, because you know all the answers. All right. How do you want to start, Richard's?
Should we start with actually maybe the first question? Richard, do you want to introduce yourself? Or do you want us to introduce you for you? Because that's always more amusing.
I'm interested in the amusing way. Let's go for that.
Oh, okay. So Richard is a part-time astronaut and part-time opera singer. We were hoping to combine both of them tonight and have him singing in orbit. But unfortunately, we've had to bring him back down to earth and get him to talk about his other job, where he works at Snowflake, teaching interesting and wonderful individuals about what Snowflake is and what cloud data warehousing is all about. I was one of those interesting individuals, so I figured this would make a good talk, because I've seen some of what Snowflake does, and it's, well, in my opinion, pretty bloody awesome. And I thought it'd be good to share the love, as such a good topic. So how's that for an intro? Is that right? Okay.
I have had some fun with the opera singing space with me in the car to myself. Also with my daughter, who one day told me to, "Dad, stop singing."
I think we've all been there. Richard, what do you actually do officially at Snowflake?
No, sure. So my role at Snowflake is a solution architect. So I get to do lots of engagements with many customers, typically post-sales stuff, to show people, to get customers who are new on Snowflake, show them why it's different to other databases and other technologies, and why it's so cool and how to most effectively use it, and how to save money using it. Yeah, it's really fun because every client you deal with has got a very different use case. Like, yeah, it's a database. How different can it be? That's what I thought. And then it turns out everyone is doing it somehow differently. There's the same patterns, but yeah, it's really interesting stuff.
Because everyone's a
SQL expert.
Snowflake. All unique and special.
At least we get cool shirts. That's nice. We do get a lot of swag.
All right, so let's start with the maybe obvious question. Cloud data warehouse versus on-prem data warehouse. What the obvious differences?
Sure thing. Well, I just happened to come with a deck prepared for such a question.
All right.
All right.
For us. Here we go.
Thank you. I'm assuming you can see this right now.
We got it.
So awesome. So if you look at, let's say, the history of databases and what they were, so you had your traditional on-premise architectures where you had your SQL Server, which has a shared single cluster or single node of the hardware. Essentially, you've got so much CPU, so much RAM, so much hard drive space available to you. But then that eventually ran out of space, or had too many people trying to use the CPU at once, or not enough RAM was available for everyone trying to use it. And so from there, people switched over to a shared nothing style architecture, where we're talking like your Hadoops or your Redshifts, where they said, let's have lots of compute nodes that work together as a single compute node, which is pretty cool. It certainly made things a lot better. You've now got more. If you need more CPU, you just add another node into the mix. You need more RAM, you add some more RAM, or you need more hard drive, you can just add a node into the hard drive, into the cluster. But it would still eventually get overloaded, because typically you'd have one of them being your leader node and the other ones would just do whatever they're told to do. And so eventually things just got overloaded. So then the world moved to the cloud, or is moving to the cloud. So let's pick on Redshift, for example, because that's what I'm quite familiar with. It was, let's take an existing technology and make it work onto the cloud. It wasn't redeveloped. It was just kind of, let's take a Postgres database and make it work on the cloud. And it was this shared nothing architecture, which was pretty cool. It got going. You could certainly scale it a lot better. But then still ran into performance issues by limited by how many concurrent queries or different workloads it could have. So Snowflake comes along and says, let's do it a bit differently. Let's make a brand new database. It's not based on any existing technology. It's built specifically for the cloud. And so, yeah, it says they call it the multi-cluster shared data. The official terminology is the centralized scale-out storage with multiple independent compute clusters. But really, what that let's look at the architecture of it. So it's a SaaS service. So we deploy it in our Snowflake AWS or Azure or GCP account. For the sake of simplicity, I'm going to go for AWS terminology for tonight, though. So it lives in our AWS account, and you send all your connections and data to us. So inside of our account, we've then got the cloud services, which is the brains of everything Snowflake. This is where the query optimizer lives. and most of the security. And then also the virtual warehouses. So when you run a query, when you're not doing anything inside of Snowflake, you're not using any compute, you're not being charged anything because, well, like essentially just a bunch of instance virtual machines behind the scenes. You say, I want to run a query, please. Snowflake creates the virtual machines, puts them all together, and then says, well, if I've just been turned on, I need some data. So it goes down to the database storage layer, which lives on S3, grabs all of the data that it needs, just the data that it needs, brings it onto the virtual warehouses, and then runs the queries, and then spits out the results to yourself. Yeah, so what this means is as soon as you, let's say you've run your query, you leave it for a bit and your server just kind of says, not doing anything, guess I'll turn myself off, and the data is all persisted down to S3.
So everyone, well, not everyone, but historically people have gone, if I want to do a big data warehousey thing, especially these days, first thing I should do is spin up a Hadoop cluster.
Yep.
You know, and that kind of is where people go, and then, you know, how do I load data into it, and how do I partition data and everything else. The comparison between here and what you're talking about, just go through that again, because I don't know if it's like quite sinks in straight away.
No, fair enough. So if you look at Hadoop, you've got to get a whole different bunch of open source technologies together. You've got to get your Hadoop piece, then you've got to get Hive that's going to run your SQL queries, Zookeeper for your job manager, Scoop to get data around the place, like all these different bits and pieces to make an entire environment for Hadoop. Whereas with Snowflake, it's all here in the one giant thing. And the language you interact with everything here is SQL, purely just SQL. So if you can write SQL in one database, cool, you can write SQL inside of Snowflake as well. Whereas with Hadoop, you've got to be looking at from a what type of which language do I want to interact with? I've written stuff in Python, or this is the .NET meetup, so I'm a .NET developer or a Java developer, and then so you've written all these pipelines in one language, and then someone else comes and joins the team, and it's like, well, I don't know Python or .NET. I'm a Scala developer, and so I've got to relearn everything a bit differently now. Whereas SQL is a very, very, very common language, and so basically every developer knows SQL, and so they can just get started. The other thing you mentioned there was another thing you mentioned there was like, if I'm going to set all this stuff up, well, that all happens for you inside of Snowflake itself. I'll jump over to the UI for a second because demos are always cool. This way. So here, this is one thing that's a bit strange about Snowflake, I will admit, is the compute services that we use, they're called warehouses. This took me a bit of time to get around as well. But
so the warehouse is not the data, the warehouse is just the querying engine.
Correct, exactly. Yeah, so I get that that's confusing. It's chipped me for a while as well. But really, you can have as many of these compute nodes as you'd like, and they can all be turned on and off independently of each other. But one thing is really cool about it, lots of things are really cool, is you can just pick which size that you want to have here. So I can say, I'm dealing with a bunch of, let's say, small Power BI reports. And so I could say an extra small will take care of this. So I've got a pretty powerful server, but I'm not reading over the top of much data. Whereas if I'm like a multinational company doing web analytics at a global scale, then maybe I want a much more powerful server available to me. And so I just make this one, let's say a 3XL. Now I've got 64 virtual machines behind the scenes. I click that and I click finish. I better give it a name. Demo warehouse, probably already got one of those, so I'll make a new one. And now it's on and available. And in about this is more the UI taking its time to refresh itself here. But that server will be available for me to run queries against straight away. And when I don't use anything with it, it'll just go, great, you haven't done anything with me for 10 minutes, so why should I charge you money for that? And it'll go and turn it off for you. So yeah, a cool thing, one of my favorite things about Snowflake is that there's like giant multinational Fortune 10 companies using us, but then there's also mum and pop shop in Southern Texas who use it once every month or two to look at their inventory, their stock inventory. They've both got access to the same compute power if they wanted to go nuts on it, or if they're little shops started to just massively scale, then cool, they've got databases that are just ready to scale with them.
Hang on, so if I've got, let's say I'm James and I'm writing software for education systems, just for example, and I wanted to run my own data warehouse, I don't need to spend like normal data warehousing stuff. You've got like a barrier to entry in that you need a scad load of data before it becomes cost effective. Can I really?
So with Snowflake, you can go for it. Whether you've got one row or petabytes of data. I think our largest customer has got. I guess that wouldn't be the most cost-effective thing, but you got a couple of rows. Let's go. Or you are running with our largest customer has got 26 petabytes worth of data with over 3,000 concurrent users, and all of them are getting sub-second response times. And that's the exact same interface that they'd be using with that giant customer versus that small customer. And yeah, super simple. The barrier to entry is definitely gone.
That's cool. Maybe I should use it for my scoring program. Just running through the I suppose the warehouse thing, you talked about it being like 128 cores or one core kind of deal. How does that, how do you figure out what size you want a warehouse to be?
Yeah, so it's not about cores. If we look at this part here, when I create one, this one here is actually how many instances, how many virtual machines are going to be behind the scenes of this cluster. So if just on that note, you did say core. So you've got essentially 8 threads available on every single individual virtual machine here. So it's the same virtual machine. There's just more of them. So roughly, you're thinking about 16 to 20 gigs of RAM, 200 gigs of hard drive, and 4-core hyper-threaded, so 8 threads CPU available to you. We don't release the exact specs because we sometimes switch instances, but generally they're the specs you can expect to get out of it. But I've gone off topic. What was your actual question there?
It was something about how do you figure out roughly what sort of size you might want?
Okay, cool. Yeah. Awesome. So this is something that there is no hard and fast rules about. It's more about how fast do you want your query to run versus that'd be how I would generally tell most customers to go for. Pick which, figure out what's the SLA for your query giving you a result time. I've got another slide over here about just that. So sizing. A few people at Snowflake ran a query that was processing 1 terabyte worth of data. So they ran the query on an extra small, and it took 5.5 hours. And so because we charge you per credit per hour, that worked out to be 5.5 credits to run this entire query. But as you can see, as we've gone up the sizes, so we're doubling the number of CPUs available to us, doubling the RAM. We've gone to a small, a medium, and a large. As we've gotten bigger and bigger, the elapsed time has gotten smaller and smaller. Yet if we go from an extra small to a 4XL, so 128 servers behind the scenes, this one here was 5.4 credits. So we've made it run 132 times faster for the same amount of cost.
Nifty.
So then, I have to fill the rest of my day with actual work at that point. Why can't I just wait for the long query to run?
Well, you could. At one of my last jobs, we had a problem whereby the data science team were only able to run their queries between 2 a.m. and 6 a.m. That was our window. And so we'd kick off the job at 2 a.m. And if it didn't finish by 6, it was terminated because the ETL job had to run at that point. Yeah, so that was pretty annoying.
Mainframes, they're still around, obviously.
Yeah, absolutely. Some of them are still around for sure. I think my current clients still got quite a few of them. Yeah, so on your note there of, well, hey, I could just, maybe I want to wait and do nothing. Yeah, cool. I personally would find that quite boring though. So I would want to beef up that server, get it running faster, and then get on with whatever I'm trying to do with the data. But if you look at this one, now it's like well, does this mean it's everybody's got this particular size of cluster now? But one thing that was about this is that it was multiple virtual warehouses. We can have as many of these individual independent compute clusters that can all be turned on and off independently. So taking your answer in a different direction,
just before
because I've got some slides for it. Yep.
Just before you do that, James, do you want to bring that question up?
Oh, hang on, I haven't been watching. Let's see. I've got some questions, but what have we got? We've got an idle price question. Yeah. So is there an idle price?
Nope, not at all. So if you look in my account at the moment, I'll cancel this one. All of the statuses of my virtual warehouse are currently suspended, so I'm not paying anything at all. Now that's a little bit wrong there. I am paying for the storage of my data, but that's a pass-through cost. That's $25 per terabyte, per compressed terabyte, and that's all I'm paying for at the moment is purely my storage. Until I actually turn a virtual warehouse, a compute cluster back on, there is no extra charge.
Right, I see. So Richard, is each of those warehouses there has a separate data store? So I mean, you've got a different data set in each one?
No, not at all. So the centralized storage is down here in the data storage layer. So I'll switch over to this one here, for example. So you've got all of your databases, or your many databases that are all sitting here, as many as you want. And so because it's based on the cloud providers storage engine like AWS S3 or Azure Blob Storage, there's no pre-provisioning. It's just, cool, I'm going to throw 1 gig worth of data at it today, and your cost just goes up by 1 gig because it's all you're using. The next day you throw 5 terabytes, now you're paying for 5 terabytes. So have as many individual databases as you'd like. But then the way you deal with that is by having separate virtual warehouses for different purposes. So here, let's have the data loading virtual warehouse that is its job is purely to run the ETL job. So let's say it runs once a day or once every hour. It turns on, does what it needs to do, and then turns off. So if it took 95 seconds to do it, you're going to be charged 95 seconds, and then you turn it off. That's all you're going to be paid charged for. Then your sales guys come along, and they're running their own compute cluster as well. So when I was at one of my other companies, Brookfield, we had a problem whereby our ETL job, our once a week ETL job, ran on a Monday morning, Monday overnight morning, so like 2 a.m. to 10 a.m. If it ran into any problems, we had to tell everybody I remember having to send an email to the company saying, please don't log into SQL Server and run reports at the moment. So like that was always embarrassing. Whereas now with Snowflake, because it's its own separate compute node, and they're speaking to the same underlying data itself, they can have their own compute nodes, they can run their own queries, and that the ETL job can run completely independently of the sales guys. There'll be no interruption whatsoever. So even if the ETL job is taking up 100% CPU, the sales guys on their Looker dashboards, completely unaffected and can go nuts on it.
Oh, cool. So, I mean, we're querying in SQL, but you said it was semi-structured data. So, I mean, SQL is pretty structured. How does it work?
Oh, that's one of my favorite features. Hey, this is actually better given than in a demo. So I'm going to switch over to the UI for this, and I've got a worksheets. Here we go. So when you first launch a Snowflake account, you've got this Snowflake sample database. It's got this weather data set. So Snowflake goes to a weather API somewhere and pulls the weather data from there every couple of hours. And so if you look here, the column structure we've got here is a timestamp, which is when the data was inserted into this table. But then it's got this variant data type. So if you're dealing with structured data, cool, we know what our strings are, our numbers, decimals, date times, whatever. But the variant data type is super cool. If I do a select star from this table here, I'll do a limit 10 so it doesn't take so long to come back. Here we go. This is what's inside the variant column right now. It's got elements, sub-elements, nested sub-elements. It's got an array, an array with its own elements, an array with its own nested elements, array with its own array with sub-elements. So it's a pretty complex JSON document that's going on here. But the way Snowflake actually stores everything is in this columnar format. So if you were to pass in a string, a number, and a date time, you've got 3 separate columns. Snowflake's going to store it as 3 physical columns. The way it deals with variant data type is it does exactly the same thing. It still uses a column to store behind the scenes. So city coordinate latitude, that is its own column. City coordinate longitude is its own column. Every single one of these is its own column behind the scenes. So when you run your select the variant column, which is V, which we just happen to have called V, Snowflake says, I'll take all the columns and I'll reconstruct it back into this JSON document and I'll give it back to you. What that enables you to do is cool stuff like this. So I can say V to get the variant, then I'll put a colon to enter the variant, and then I want to get to the city element. So if I run this query now, well, this variance column has got everything, the entire thing inside of it. When I run my query and say, just get me the city element of that, please, it constructs, it says, well, the only ones that could be existing in that is city, coordinate, latitude, longitude, and all these. So the only data that gets transferred from the storage layer onto the compute service is just those columns, because Snowflake's already looked at it and figured out what the schema is. And you can keep going lower with this. Like I've got city,
So
we can go
just on that, that
city
means it's not doing any JSON parsing or anything like that. It's done that on ingest and then you're done.
Yep, it's done that on ingest, and now you can still deal with it as structured or semi-structured. You can deal with it as semi-structured, like to you, it's still a JSON document, but to Snowflake behind the scenes, it's actually structured. It's now saved it as structured data. So I can just use dot notation to go lower and lower, and now I can get access to the individual columns that I need.
Oh, that's cool. So behind the scenes, is it just a column? Like, is there a city dot coordinate dot latitude column behind the scenes in the storage?
In the storage, yes. So the way Snowflake stores data is as a columnar store. So if I look here in this particular, let's look at this table as an example. Here, this has got structure on it. So this customer key is a number. The name here is stored as a variant. As a varchar with 25 characters. So the way that the semi-structured data is physically storing the data is it is structured behind the scenes. But when you query it and say, give me the city dot coordinate element, please, Snowflake goes, well, I only need these 2 columns. I don't need the whole JSON because I parsed it when you loaded it. I only need to bring up or copy along just the 2 columns to answer your query.
Oh, nice. So does it make tables as well out of the data that you ingest, or is it just one really broad set of columns?
So when you're dealing with the variant data type, you're loading this bit here, you're loading everything into the variant. And so it can change the structure as it goes. So it doesn't have to be the same thing as it goes. Like if I use an example, I've got, where's my other one? I had it in here as my sysadmin. Use role account admin. Refresh, and I should be able to find my Snowpipe demo. Here it is. Oh, did I delete the data out of it because I'm a dummy? I did delete the data out of it because I'm a dummy. All right. Well, the point is you can change the structure of the variant. So today you're embarrassing. You've got 4 elements in your JSON right now. The next time you load it, you've got a different 4 columns. The next time you've got 3 different elements or columns. The variant data type in Snowflake goes, all right, that's fine with me. Please don't tell me what the schema is, and I'll just make it happen for you.
James, do you want to bring Sarah's question up as well?
Yeah, let me switch back.
Since it's relevant.
Do you need to provide schema to Snowflake? Here you go.
What was that, sorry?
Sorry, I'm not sure if you can see. So Sarah's asking, do you need to provide any schema to Snowflake?
So when you're dealing with semi-structured data, no, Snowflake will just do its schema on read, though you're quite welcome to load CSV, Parquet, or any kind of structured type straight into Snowflake as well. So we'll deal with structured and semi-structured. And as you can see, I've got a semi-structured data living directly alongside structured data. So that's perfectly fine. You can combine the two together.
All right. How do joins and things like that work?
So joins, you mean like just joins in general, or joins specifically
so say we have really
over variant?
Need to connect this variant of weather data against our product information or something. Can you do that?
Yes, you can. I like that question. So I've got a demo over here that I was going to save for later, but you've asked. I'll skip through the query.
Sorry, I'll take this off the track here.
No, you're okay.
We like
Go
going
for it,
off
man.
track. You know us, we never stick to
Versatility, man. So here I have got structured data, an event time, a string, an integer stored alongside variant. So I put together some fake data, pretending that I had a website that had web tracking in it. So this is the data that has been sent as people go to my website. So in this case, I've got the Snow Store, the Snow Swag Store. People come here to buy different types of products. So they're at the Snow Shop. When they log in to, or when they you have to be logged in to use this website. So you've got a user ID, and web tracking works off sessions. So every time you come to a website, you'll get a different session ID. Leave, come back an hour later, you'll get a different session ID. So we can tie it together to say what pages you went to in a given session together. It can also track, hey, what device were you on? So with all of this being in semi-structured data, when I was with Channel 9, we were using Adobe Analytics, and when we added a new column into the tracking, we had to first go and set up the data warehouse, tell it, hey, there's going to be a new column coming on this day, so look for it in the variant, in the JSON data we're sending you. Then we'd have to read your ETL jobs to be prepared for it. Like, it was an event to add a new event into the tracking. Whereas with Snowflake here, we don't have to tell Snowflake what the schema is. We can just throw more data at it. Like as an example here, I'm just going to do some data aggregation. So I'm saying inside the variant column, go into the session ID. Also, can you please make an array of all of the pages that people went to within this particular session? So grouping it by session ID. So now I can look in here and I can see this particular session ID in its session went to all of these pages in the one session itself. So that's pretty cool. But then your question specifically was, well, how do I join things with that? Because we know that it is structured data behind the scenes, we can take our semi-structured data, which is from my common table, my CTE up above, and because it is structured, we can just join it over to structured data. So here I'm going to join it to my dimension products. Here I'm going to join it to my dimension customers. And when I run this query now, give it just a moment to run, takes about 5 to 8 seconds or so, 5.3. Now I've got semi-structured data, which is going through and saying, what did you add into your shopping cart? And in here, I can now take that shopping cart product ID and the user ID, and now I can go and look up from my data warehouse, what was it someone was adding to this to their shopping cart, and who was it? Now, this is fake information, by the way. I'm not exposing PII.
Bit of PII data.
Yep. So this example here, I've skipped this whole middle section, which what it was doing was saying they added something to their shopping cart and they didn't actually finish the shopping cart. They didn't buy it. So who were they? Let's go target them on Facebook and send them Facebook ads, or like send them emails to say, don't forget to buy it. Here's $10 off. But that was answering your question on joining structured and semi-structured. So anything you can do to structured data, you can do to semi-structured data, because behind the scenes, it is structured data anyway.
I see, and there's some interesting stuff as well. It's interesting extra extensions on SQL, obviously, as well. What's the input goes to RDV cut mean?
This part here is where I'm doing a flatten. So I've got an inside of this. We'll go back to the weather data. In the weather data, I have got an array, and I want it to be that this one single row. I want to have this one JSON element, one JSON document that comes in. I want to make a table of the output of the array. So every item in the array should just go whoop and now give me a row for every single item in the array and be linked back to the source that it came from. So to do that, I will copy paste this query for the sake of ease. And we can now say from there, we can join over to our lateral flatten. When we're doing that one, we need to say, what am I going to flatten? What's the array I'm going to flatten? And then I'm going to pass into there my variant, and it was the data array, I believe. Data with a little d. So that's what that one there was doing. It was the shopping cart in the other example, saying flatten out the shopping cart. So if they've got 4 items in there, let's show that Richard Moore tried to buy a shirt and a webcam cover and a USB stick in 3 separate rows.
Oh, I see. And yeah, I take it you can do from multiple different like databases there in the from.
Yep.
Could you pull something from a different database there as well?
Yep, absolutely. Because it is a centralized data store, just join the entire things together.
Oh, pretty neat.
Awesome. James, do you want to switch to a couple of the questions?
Yeah,
Alan?
we'll bring up some questions here. So we've got one from Alan. Yeah. So full text search, can you do it over everything?
Snowflake does not have full text search at the moment.
The answer is no, Alan.
Yeah, the answer is no. I can't. We don't have that. I can't give you a timeline. But I am pretty sure we're working on it.
That's a good question. All right, and we've got another one from Alan as well. So he's asking, can I restrict semi-structured data to reject anything that doesn't match a specific schema I have?
No, you at this point, no. So you wouldn't be able to do that by loading straight into your semi-structured schema itself. But what you can do is, the way I do that is, let's say your data was an S3, I'd then load it into a staging area that would be like a table inside of Snowflake. And then I would move it over to my, let's call it the data lake or the data warehouse or the curated layer or whatever. As I'm moving things from staging, which can come in with anything, into the data lake area, I'd be saying, please only select these few columns out of there and then make them be a variant inside of my data lake. And then you could have a control file that would be a mapping table somewhere to say, these are the columns that it should pull out of that particular JSON document.
Right, so could you automate that so you didn't have to do it manually?
You could write a stored procedure to help you pull it off, but it's not something that's built into Snowflake. The short answer to that question is it is not built into Snowflake to enforce a schema of a variant.
And Alan's got one more question as well. Triggers.
What was it, sorry?
I guess
just triggers. Triggers question mark.
Yeah. Are there triggers? I guess, Alan, that's what you're asking.
Oh, triggers. Right. Sorry. Triggers. No, there are not triggers in Snowflake. Not at this point.
Any constraints you can put in?
So there's the thing about big data databases. This is not just a Snowflake thing. This is across all of them. You can put a primary key. You can put a foreign key constraint, and Snowflake's going to go, thanks for telling me, and then it's going to straight up ignore it. All of the different ones are going to ignore it. So when you're dealing with like petabytes worth of data, for it to go back and double check, have I seen this ID anywhere before? It's just kind of too much of a CPU. So generally, no, you build that into your ELT process to say, cool, only accept certain values or make sure that they don't exist before you load them in. And so the reason you can still put them on there, though, is that tools like Tableau and Power BI and schema writing tools like SQL DBM, they want to know what tables link together. And so from a metadata perspective and other tools, it's really handy to still have them. But yeah, Snowflake doesn't enforce them itself.
Fair enough. And we've got one more question from Alan as well. So
He's on it. He's on fire.
that's good. He's
Go for it, Alan.
really interested. So it says, can I ask Snowflake to tell me the schema it is built for a semi-structured column?
You can I'll go a roundabout way for this one. Where is it? Semi-structured, semi-structured. Get the schema. Here we go. This is my list of demo scripts, by the way.
Just what we do.
And I come prepared. All right, so what we're doing with this query here is we'll break it out a little bit. I'm saying, get me, there is no way for you to go to the variant and say, across all of it, tell me all of the schema, please. No, but you can say, look, given this particular row set, so I'll get the past 100,000 rows or so, can you please tell me the schema of those particular pieces there? And yes, it can. If you give it a subset of rows, then it can tell you, like, here are the columns that are now stored behind the scenes. City coordinate to latitude, that's a decimal. City country, that's a varchar. So yeah, you can do that. And you'll also see that, hey, Richard, you're dealing with an array there. How does Snowflake store an array of columns? If it's storing it in a columnar format, it says this is the 0th position. I don't know how to say 0, the first index, but it's a 0. Anyway, so it's like the terminology I never got on that one. But yeah, so it can always tell you can tell it, or it stores it as a physical, it stores it as a table behind the scenes like that. Yeah, but this is how you can look at the structure. How you doing? How you doing? 1 second, guys. Kidlet interruption.
So this is where we just talk amongst ourselves. Oh, what about index? Sarah, that one was before. I think Richard was just saying that indexes are informational more than anything else. So primary index, secondary indexes, if that's what you're asking about.
Yeah, it doesn't make it works by that.
Yeah, because indexing is too expensive for a large data warehouse.
We're just putting words in, Richard.
The other Richard. Which Richard? That Richard.
Oh yeah, the Richard. Other Richard's putting Richard's words in. So yeah, Sarah's just checking whether there's any indexes, and we said not, but you can correct us if we're wrong.
So there is not indexes. You're correct in that style. So Snowflake relies on knowing what data is in the micro partitions themselves. So the micro partitions are the physical files that Snowflake puts in. So if you, let's say you've got CSV, you've got JSON, you've got Parquet, you load it from S3, Snowflake's going to go, cool, thanks for that. I'm going to store it into our data format, which is called FDN files. So the only way to access these is to run a query and go to the virtual warehouse, get the data, and the virtual warehouse gives you the result set. But let's say you've got your question.
Yeah, it might be worth just, if you can, just talking about those micro partitions and how they fit together.
Yep. No, that's the plan right now. So the micro partitions themselves, if they've got all of the columns of the data in there, and they've got the micro partitions know roughly what's inside of them. They know what their min value is and their max value for every single column inside of every single micro partition. So that acts as a pretty good index anyway. So if you've got 10 years worth of history here, if all of these micro partitions represented one table that was 10 years worth of your let's say sales history, then when you run a query that says select star from the table, show me all actions taken over the past month or so, you would expect that Snowflake would be able to say, scanning the entire table would be a bad idea. So I can figure out which is the only micro partitions I'd actually need to answer that query. And where that happens is up in this cloud services metadata manager. So the metadata is what stores all of the micro partitions for the table, like the references. This table speaks to these 20 micro partitions. And inside of each of those micro partitions, you can expect to find this data. So when you run a query, it comes down to the optimizer. The query optimizer says, for me to come up with a query, I guess I better know what data I'm going to speak to. So it goes and asks the optimizer, hey, optimizer, I'm looking for the past 30 days worth of data in this table. Which micro partitions could I even possibly need for this? And the metadata would mean the green ones. And then the optimizer says, thanks, I'll go and I'll work with the green micro partitions. So then the optimizer, it doesn't actually execute the query, but it came up with the actual execution plan. It passes it to the virtual warehouse. And the virtual warehouse says, according to this plan, I need the green micro partitions. I'll go and get them and I'll copy them onto the virtual warehouse. Now you might go, that sounds pretty much like an index because it kind of is an index, but it's not because it's not an actual index. Yeah, that's how we work off them. Yes, darling. I'll be able to help you with that in a moment. Okay.
I'll bring up Alan's next question.
Okay, so micro partitions, partition function. So the short answer is you don't have to worry about it. Richard will no doubt talk about it, but it does the partitioning for you based on need effectively. So you don't have to manage it like you would with a normal Hadoop cluster or something like that.
Yeah, that's right. As you load your data into Snowflake, Snowflake's going to take care of the creation of all of these micro partitions for you on your behalf. So that means it takes a pretty good guess at how it's going to work, and like 95% of the time it gets it right. But you can also take control of it and say, no, Snowflake, I want my data to be specifically stored in this physical style. And then, cool, Snowflake will go, all right, then you know better. We'll go for what you want it to do because you are the customer.
Oh, that's good. Yeah, it always seems with databases, most of the time it works, and then suddenly, yeah, there's a bit more control. Suddenly it decides to do a table scan when it shouldn't, or whatever.
And then people make the performance worse.
Yes. Well,
so something someone asked there was, does Snowflake have any indexes? And while we don't have any indexes, like primary indexes for most of the time, there is, does this one have it? Which table of these is it? Let's pretend it's you, see what we get. It's either this database or the other ones that got it. If I do select star from this, let's go top 10 from there, give me something, it's hiding, customer key. So there is a particular feature called the search optimization service, which does actually put an index over the top of your entire table. Now it's to be used for like, I'm looking for individual or like maybe 10 to 20 rows or so. So your data is still stored with the micro partitions, but then we also say, let's go ahead and store it as an index as well, because you told us to, because we expect that your queries are going to be like where something is equal to or is in something. And then when we run that one, it'll then use the search optimization service to come back with that instead of scanning the micro partition. But you wouldn't go using this on every table. You'd identify that you need to first. But yeah, most cases, no, Snowflake doesn't actually have indexes.
Cool. All right. What about getting data in the first place?
So getting data in, you want to get it firstly from your source systems, bring it up into the cloud. So I'm using AWS for my example, so I'm going to get it into my S3 buckets first. Once it's in there, Snowflake can speak to your S3 buckets. And then you can say, all right, take it from the S3 and copy it into my final table, into your final tables there. Now, how you do this is you can trigger it yourself and say, I want it like whenever I run this query, maybe you've got a job that runs at a certain time, like a cron job that's running it, you can tell it to do it. Or what's more likely, and can work out to be a bit cheaper, is to use Snowpipe. So you've got your data sources, they're pushing data maybe to Kafka or Kinesis Firehose. That one there can then, like the cool part about these, if you're using Kinesis Firehose and you've got a record comes in now, a record comes in a minute later, a record comes in an hour later, Kinesis Firehose will batch that set up together and say, hey, it's been a certain period of time. I'll output my buffer to S3. So now you can have your data stored together and compressed in a nicer style. So when it hits here, you can then, instead of you having to trigger the copy command yourself, you can put an S3 event over the top of your S3 bucket. Same thing for Azure or Google Cloud as well, whereby it sends a notification to Snowflake, and then Snowflake says, "Ooh, a file! I'm going to go and load it right now because you told me to." And so it's when data arrives to S3, it loads itself straight into the database for you.
Mm-hmm. What happens if you've got like a log file or something like syslog or whatever? Can you send that in, or do you need to pre-process it into JSON or CSV or something first?
So I've worked with customers who have decided it was better for them to pre-process it. So this one customer was to say, let's put it on S3. We'll use, when it lands on S3, we'll use a Lambda S3 event to trigger a Lambda to write it to another S3 bucket, and then we'll load it into Snowflake from there. But I've worked with another customer who said, well, that seems a bit overkill. I mean, we've got the power of Snowflake here. Let's just load it straight in as a giant string, and then we'll do that processing inside of Snowflake itself. So options.
That works.
Right, and the tools are there for string like regexes and that sort of thing to chew it up.
Yep, absolutely. Absolutely.
Got to use those compute cycles somehow. Might as well do it on a regex.
Yeah, why not?
What's that? It's big data? I'll need a 4XL for this.
You got any questions?
Yeah, you want to hit that question?
And we've got one more from Alan here.
Cool.
Yeah, so he wants to know, are there any other options besides SQL, like REST APIs or anything else?
Ooh, all right. So at the moment, it is SQL. There are the drivers that you can get. So I'll come up to help and I'll go download. My favorite feature of Snowflake is when it says go download a driver, it says go download it from somewhere else. I want to get the Spark driver. Go download it from somewhere else. No, so there's the Python driver, the Node.js, the .NET, the Spark, the Go. There's a CLI client, but specifically around your API one there, we've got a private preview going for Snowflake's web API, whereby you can just fire off the query to your account. I'm here on AU Demo 14, so I could send a query to my API, and I'll get back a JSON response for my columns.
Cool. And do Alan have another one?
Yeah, he was asking about the email in the query you had before.
Okay.
Yeah, that one. Because I think it was data masking related. He was just wondering if it's per column.
Yeah. It is, so it's not per column. So, I just happen to have another thing for this, don't I? Hey. I get these type of questions all the time. So the way Snowflake encrypts your data is you give it to us, then we're going to store it on our S3 buckets or our storage layer. So it's always encrypted, but it's encrypted at the micro partition level. So we use our own or the cloud providers not secrets manager. Encryption key provider, that's what I'm going for. So then we will encrypt it at the account level. Then we'll encrypt the master key with the table master key as well. And so all the files get encrypted there. So you can also, some customers will say, I'm not comfortable with you having the only key to my encrypted data. So then they'll say, I want to introduce my own key as well. So then they will take your key and our key. We'll combine them into the secret secure, that one I like. So we'll combine the two to make a third key, and then we'll use that to encrypt all of the data itself. So then if you were to, this happened at a customer once, someone in their account removed the actual encryption key itself from AWS, and Snowflake no longer had access to figure out what the composed key was, and so that customer lost access to their data. Damn it, that was unfortunate. But then another aspect of that is how often do we do key rotation? So the table master key, we'll use one for April, then in May we'll switch over to a different one, then in June we'll switch over to a different one. And so this is all handled entirely behind the scenes for you, fully transparently. And then you can also say, all right, it's been a year since I had my my data redone. Snowflake, can you please go ahead and just rekey my entire table, all of my data, and we'll go, no trouble. We take care of that for you. It doesn't cost you anything. We do it behind the scenes. There's no downtime for you. But I believe your specific column question there was, is it column level encryption? It's file based, so the micro partition files themselves are what actually gets encrypted.
So just, I know we're hitting time, but maybe just bring up that slide about what's actually in a micro partition.
Sure.
Because that one, at least for me anyway, I think it's kind of cool.
Here we go. So if this is the logical structure of your table, you do select star from table. You get it looking back with name, country, date, like it looks like this. There's your select star. But the way we store it behind the scenes is as these micro partitions in a columnar format. So micro partition 1 says I've got just these rows. And so here we can say to construct the blue or the dark blue row, we need to pick from each of these columns that would restructure itself into the logical structure. But then we've also got, if we look down at the date, this is American date. So I've got the 2nd of November, 2nd and the 3rd of November, 2nd, 3rd, 4th of November, 3rd, 4th, and 5th of November. So if you were running a query that said, I want to find all the people who bought something on the 5th of November, the optimizer would say, hey, metadata manager, I'm looking for the data for the 5th of November in this table. The metadata manager would look at the individual min-max values for all the columns and go, well, the only one that could possibly contain data is going to be this micro partition right here. And so that's all it's going to pass over to the virtual warehouse.
Which is pretty cool.
Cool. Does it have the micro partitions then by the name or something else, like keyed by different private partition keys? So
that part there is something you just don't even need to worry about. Snowflake handles all of that for you behind the scenes. But if you want to know, like, what is the file name behind here, I'm imagining it's probably some GUID that Snowflake makes up.
No, I mean, right, if it's got min-max value for, does it have multiple copies of the data by the different columns so that it can get the min-max value? Like, say you're looking for things between, A and C or something, right?
Like here, the name says I've got from A to Z.
Yeah.
Yeah, I get you. So no, it doesn't. So the way it does it is on ingestion order. So that typically means you're going to have it by day, because most of your ETL processes are going to be time-based. So you're going to load today's data today, tomorrow's data tomorrow, the next day's data the next day. Like, you have naturally made a cluster of it being ordered by day. But they're one of those places where you can say, I need to take control of this because it should actually be stored by type. Like, as a real world example, a customer here in Australia, financial services customer, they said, Snowflake, for like 99 of our queries, of our 100 queries, your performance is fantastic because we've got it clustered by date. But I'm now looking for the lifetime value of a customer where customer ID is equal to T. And now it has no idea where it is. And so it has to scan my entire couple of terabytes worth of micro partitions. So what you can do is, once you've identified that your cluster key, the way Snowflake is stored, it is no good, or is not working most optimally for you, you can say, look, it works good the way you've done it for some queries, but I want you to also store it another way. First, I wouldn't say ordered by, but roughly ordered by this other column. Oops, sorry, no. So then you are storing 2 copies of the data, but it's only doing that for when you tell it to actually do it.
Yeah, fair enough. So the default is basically by date, but you can have it by name or whatever, ID, whatever takes your fancy, if you set it up that way.
Yeah. If you tell it to, yeah.
Fair enough. But then if you had a terabyte of data, you'd have 2 terabytes of data stored.
Correct. So maybe you identify that actually that other query that I'm doing, it's only going to use 2 columns out of this. And so you can say that that subset of data that you want to be ordered by name should actually only have the columns that you want it to be in there. But then again, it's $25 a terabyte, so it's ridiculously cheap anyway.
Right, sounds good. Have we got more questions from?
We've got a few more sitting there.
Cool. So before you answer those, I've got one more fun story, which is a customer had 100 data sets that they needed to load every hour. And so what we did is we set up a process that turned on 100 separate compute virtual warehouses. And then after it had loaded all the data, it just immediately turned them all off. So this customer was turning on 100 medium servers, which was 400 virtual machines. Every hour would turn on for about a minute or two, and they'd turn them all straight off. I love that story. I think it's great.
It's quite neat.
That is cool. James, did you want to hit Beepin's question?
This one, here we go.
That one there.
Maybe, do we cover that one already? You're assuming dates are sorted or it's optimizing the storage and sorting on its own.
So we covered
So no, it's not actually storing by day. It is. Yeah, it's ingestion order is the way it does.
Mm-hmm.
If you happen to load it all at once, cool, it's all loaded together. Snowflake doesn't go, oh, I'll just do date because date's pretty good. It doesn't do that unless you tell it to.
Mm-hmm. Right, so if you upload it in primary key order, that would be the order that it split the micro partitions.
Yeah.
That's cool. And we've got a question from Sarah as well. Is micro partition like sharding?
No, I'm not going to go. It's like sharding. It's more like partitioning your files together on S3. Like if you think of, let's say you've got a whole bunch of data on S3 and you're going, all right, data source 1, instead of grouping it all together, I've got a few thousand files. I'll do it by like 2021/01. I'll put all of January's data in that subfolder, and then I'll put all of February's data in that subfolder, March's in that one. So it's the micro partitions are more like partitioned actual physical partitions in your file, in your data sets together, except we do it for all columns for all the data that you've got on all columns.
Cool. All right. I think, Richard, we're going to pause the questions there because otherwise I think we'll be here for a while longer. And we did say it's only an hour. And you were like, way too short. I need a day. But is there any particular, I suppose there's one other highlight might be just worth talking about while James thinks up some questions for the prize. There's a thing in Snowflake around data sharing, which is somewhat unique, I think.
Yes. That one's very, very, very cool. Hey, so looking at the Snowflake architecture, we have got, it's a shared service. So my account in AWS is in the one Snowflake instance, and all the other customers who are in Snowflake AWS are also in the same deployment. So we're all sharing the resources here. Now they're fully separated and we can't access each other's data except unless we explicitly give permission for them to actually access our data. And so you're in your own S3 buckets, your data is completely separated, but we're all sharing these virtual warehouses and we're sharing these cloud services layer here. And so if I wanted to share data with another customer, I can come up to my shares area up here. And I can say, oh, I've got to be the account admin for this, so I'll switch over. I can say, I've got this data set here that I think Richard, the host, would really enjoy. Maybe we're doing some stuff together. Example off the top of my head, creative. Failed me. Yeah, well, here's an example, like the GNAF or the GNAF data set, the address data set of Australia. They put this into their Snowflake account and then they say, hey, anyone, if you want to get access to the data, we're storing it anyway. How about you can just come to the data marketplace and just grab it? And so it's let's say it was like 2 terabytes worth of data. I actually don't know how large it is, but I can go to their account because they've given me access to, and I can make my own database off their database. So I've called it the GNAF AU data set. I come into my own worksheets here, and I'll find that I've got that right here. So GNAF AU, you'll see the little the arrow pointing in. That means this is not your data set, Richard. This is being shared with you from another account. Now that's one that's open to everybody, but I can explicitly say, look, I want to share my tool shop data set specifically over to James. And so I can say, I'd like to share this table, just this one table, or just these 3 tables, or just this view over to another account, and then they can use their compute to query my data. And what's so cool about that is as soon as I run an update statement and change the data on my end, as soon as I commit the transaction, it's available to the other account as well, like instantaneously. There is no delay.
Because it's not a copy of the data, it's literally the same
bucket
micro partition that we're querying.
Yeah, I'm saying it's my data. When I get it, I get access to it, but I'm going to give you access to query my data. So go for it.
Yeah, very nice. All right, James, did you come up with some questions?
All right. So, well, thank you very much, Richard, and Richard. Especially Richard Snowflake for answering all our difficult questions that we chucked at you and from the group as well. So, well, now over to the questions for the group. You've had your turn, now it's our turn. So one question for you. Yes, in what does Snowflake store its data? First question.
This is for the JetBrains.
This is the JetBrains license.
Boom!
Right. That's pretty good.
FTN files. Wow.
Wow. Okay, that's a good answer. So from Paul, please send me a message on Meetup and send me your email. Sorry, on Meetup.
Cloud.
The cloud. Yes. I think we'll stick to Paul's earlier.
Yeah, you were second to answer, so we go with the first answer.
That's right. I think that's a good answer, the first one. All right. And the second question is, what order is the data in the micro partitions? And if people don't have that one, then I'll give you an easy one.
Waiting for it.
The answer is the cloud.
You can't just keep putting cloud. Ingestion order from Sarah. That works.
All right, Sarah, haven't you got like 5 licenses already? But
she's reselling them on the side.
Sorry?
Nothing.
All right, Sarah. So yeah, send me your email as well. I probably got it already, but you might as well send it to me as well, and I'll send you through another license. But I mean, you have been to a lot of meetups, so you deserve a lot of licenses, clearly. All right, so that's the giveaway part of the evening. What else do I say? Yes, does anyone have any talks they want to give or talks that they want to hear about? Also, either stick it in the chat or send me a message or Richard a message on Meetup. We haven't had anyone from the group present for a while, so
we should do that.
It's a good chance.
She loves brains. Brains. Yeah, and for those having an Easter break, going away, enjoy your holiday period, as long or short as it might be. And if you were planning on traveling to Queensland, sorry about that. Enjoy a staycation instead.
Yeah,
that's me.
Itself.
I think we're pretty much done. So thanks, everyone. Enjoy your evenings. Enjoy dinner. Say hi to your family. And we will see you next month. And thanks again, Richard, for spending some time with us. It was fantastic.
No worries. Thank you very much for having me, guys. A lot of fun.